Well, hello there! I hope you're having an amazing day and that it's true that you have false to say against learning new stuff about Boolean data type. Huh? You see what I did there? Well, maybe it's still too early to understand that joke, so to say. But yeah, today we are going to start our discussion and get familiar with the Boolean data type. What are we waiting for? Let's get right into it! Okay, so basically, as usual, the first thing that we need to do is to actually define what Boolean data type is. And to do that, I think the best way would probably be to actually talk about its potential values. And there are just two potential values. We have true or false. So yes or no, light or dark, white or black, whatever you want to call it, but we have just two options. Right now, probably the question arises, why would we dedicate an entire lesson to just true or false? We are basically done with it. We already covered all the potential values that it has, right? Well, there is quite a bit of stuff when it comes to Booleans, because we use them so much in coding in general that we have to dedicate at least one lesson to them. The scenario where we use Booleans is the scenario where we have only two potential outcomes. We have one that is true and the one that is false. And this, when you think about it, in reality, you can explain a lot of situations that only can end with one of those two scenarios. And that is basically why it is so essential to have Booleans in our code. You can use integers as our Booleans, so instead of Boolean values. You can use, for example, just saying, you can use all the negative numbers as false and 0 and all the positive numbers as true. Yeah, that would work 100%, there is no problem there. But when you think about it, it would be really messy to go through the code and just try searching for any number and then compare it and then work with expressions made of numbers instead of very simple true or false statements. Our next topic has to be the way that Boolean values are displayed in memory. So basically, we only have two options. And when you think about it, only one bit of memory would be enough to store both of these options. So 0 would be false and 1 would be true. Basically, it's very simple. But yeah, things are not that simple with today's processors because we are using large portions of data, and using just a single bit for our true and false statements would actually make our code run slower than it's running right now when it takes 8 bits of memory. So yes, Boolean data type takes up 8 bits or 1 byte of memory in Rust. Even though it is really not necessary, 1 bit would be enough to store all the potential values. And right now, I feel like you are still wondering, why are we using 8 bits of memory for something that we can represent with a single bit of memory? Because isn't the whole point of Rust to be optimized and to use as little resources as possible? And the answer is yes and no, because in this particular case, the fact that we are using 7 bits of memory that are completely unnecessary makes the code and the compiler and our CPU run much faster. Because if we were using just a single bit for a variable that is of type Boolean, it would be way harder for our CPU to jump through the stack memory and to figure out where is the next variable. Because each variable has to have its own size, and nowadays there is the minimal size that our CPU can jump through the memory. And basically, it cannot go lower than 8 bits or 1 byte. And yeah, this is a very advanced topic, and it will require a lot of discussion about the way our CPU works, our memory works, our instruction counters work, and all that stuff. So if you're interested in that, you stay tuned because I definitely will cover this because it's very exciting to know how things actually work under the hood. But for now, we're just going to leave it unveiled. You just know the basics, and basically that's all you need for now. Later on, we'll extend on this knowledge and we'll make you a true professional that knows how everything works under the hood in its core. And yeah, that's basically all about Booleans, so right now I think it's a great time to jump right into Visual Studio Code to show you in practice, in real life action, how Booleans actually work and how we can manipulate them and use them. This hanging out session is not going to be such a long one. I mean, at least in the Visual Studio Code environment, because the stuff that we need to cover in practice is very simple and we do not have to spend too much time discussing it. So, let's not waste any longer and let's get our hands dirty. So basically the first thing that we need to do is create a new project and open our main RS file and find our main function inside of it. And when we have done that, we can jump straight to creating our Boolean variables. And basically the only thing that we need to show here is going to be that we can create variables with explicit and implicit data type. So let me create our first Boolean variable here, and this one is going to be explicitly typed one. So we are going to specify the data type, so bool, and we are going to assign value true to this variable. But also we are going to create another variable that is going to have something a bit different. So we are not going to specify the type for this variable because we want it to be implicit, and then we are going to assign the following value to it. We are going to put 6 equals 5. But if you take a closer look, you will see that we have 2 equals, not 1. So we have 6 equals 5, and you're about to find out what that means. But you can see that compiler has successfully inferred that the data type is Boolean here. But when it comes to the part of 6 equals 5, you're about to find out what is it all about. So, thank you for watching and goodbye. You're heading back to our theoretical discussion. And now, our topic is going to be dedicated to operations that we can use on our Boolean variables. So have in mind, I'm not going to cover them all because there is quite a few that I'm going to leave out of this video because we will cover them in the future. But for now, we are going to talk about only the operations that are most commonly used in our day-to-day lives as programmers. So basically, you are going to need the rest only if you're doing some very specific stuff, and like if you're a general programmer, the stuff I'm about to share should be enough. The first operator we are going to use and cover here is going to be the comparison. So basically, its representation is 2 equal signs. So if you're using a single equal sign, that means that you want to assign some value to some variable. But if you have 2 equal signs, one next to another, that means that you want to compare 2 values that you have at hand. Right now, you probably think that we have just 2 options, and that is to have 2 Boolean variables that are like just hard-coded Booleans and nothing more than that. But the reality is a bit more complicated because you can have a very complex equations that can be compiled down just to a single true or false value. And then you can compare quite a few of those very complex expressions, and yeah, things can get very complicated very quickly when working with Booleans. So let's try and discuss what is it that you need to know in order to be able to work with them effectively. And to explain this, I feel like the best possible approach would be to just reflect on this table that we have right here and to talk about all the potential scenarios that we have at our disposal. So when we are comparing two values, no matter how we got them, so it doesn't matter if it's a Boolean variable or it's a whole expression that was compiled down just to a single Boolean value, it doesn't matter, but we're comparing two Boolean values. And all the scenarios that we have at our disposal are going to be the first one, true and true. So when we are comparing true and true, it's basically the same. So those two values are equal. So we should get true as a result. Because when comparing two values and when we are trying to figure out if they're equal, we want to have a result true when they are equal. So true and true is equal, which means we get true as a result. The next scenario is going to be true equals false. And this is not the case. So we will get false as a result because true is not equal to false. And our next scenario is going to be false equals true. And again, these are not equal. So false is not equal to true, and we get a false as a result. And final example is going to be false equals false, and this one is true because even though false is like false, false is equal to false. I know it sounds very weird and very confusing when you just listen to this, but when you take a look at the table and really think about the expression and the logic that is taking place here, you should agree with this and you should understand why we are getting the results we are getting. So yeah, basically that was comparison or equals operator. Right now we can discuss about a negation operator. So we have two options here because this is not binary operator, so that means that we do not need two values to work with. We need just one, which means that we are working with a unary operator. And logically, when we are working with a single bit and a single value, that is Boolean, we have true and false as potential values. So when we negate true value, we get false as a result. And when we negate false, we get true as a result. So this is very simple. You're basically just flipping the value. If you're working with true, you get false, and if you're working with false, you get true. Ah yes, I almost forgot. When it comes to negation, the way you can indicate to our compiler that we want a negation of some Boolean value, we are using exclamation mark as a symbol in front of the variable that we want to negate. Just remember that. Now it's time to step up the pace. Right now we are going to talk about OR operator. So we're talking about logical OR operation. And this one basically can be translated to the following expression. If you're working with two values, again this is binary operators, so you need two Boolean values that we are using this operator on. Now let's discuss how to actually tell our compiler that we want to be using OR operator. Of course, for this we have a designated character, and that is straight line. And I'm talking about this character right here. So yes, when you use it, the compiler is going to translate this into the following result. And here is our handy table with results. So when we have true or true, that means basically that only a single value has to be true in order for our expression to result in true. Because we are basically saying this value or this value has to be true in order to get true as a result. So when we have true or true, that is true because one or more than one value is equal to true. Our second line is going to be true or false, and because one value was true, we are getting true as a result. The third scenario is going to be false or true, and again we are going to get true because at least one variable was true, and our final situation is going to be false or false, and here we get false because none of the values were true. I hope that this makes sense. And if it does, we can jump right into our discussion about AND operator. Basically, the character that we want to use is AND character. I'm talking about this one. And right now that you know that, let's go right to our table. And as the name suggests, in order for this operator to give us true as a result, both values have to be true. In all other scenarios, we are going to get a false. So in the first scenario, we have true and true, which gives us true. The second scenario is going to be true and false, which is false. The third one is going to be false and true, which is again false, because we need them both to be true, right? And finally, we have false and false, which will result in false again. And I have one more operator which is a bit less used in reality, but I will include it here because it's very similar as the other ones. This one is called XOR. So for it we are using this character right here. I don't know what's the name of it, but yeah, this one. And the situation here is going to be the following. So let's go to our handy table and observe our potential situations. So we have true XOR true. This is going to be false because XOR gives true only when values are different. So now that you know that fact, you know that true XOR false is going to give us true, and you know that false XOR true is going to give us true again, and finally false XOR false is going to give us false. So we just covered all the basic operators that are being used on our Boolean values. Congratulations! And yes, believe it or false, we are done with our lesson about Boolean data type and the basic operations we can use on Boolean data types. I hope that you enjoyed this video and that you found it useful. And if you did, I would like to kindly ask you to subscribe to this channel and like this video, because it really helps out both me and the channel to grow and get more people to reach this content and learn from it. So I would like to thank you in advance for doing that. And now it's time to talk about our next video. Because in our next video we are going to be talking about number literals. I know it sounds weird and you probably do not know what those are, but stay tuned and join me on this adventure and you will find out all about it. So have an amazing day and goodbye!